Hello everyone, so let us start. This is question number 11 of GATE 2023, and the question is there are two function f and g is given, and there are two option p and q, the two statement p and q. The first one is f has a saddle point at 0 0, and second g has a saddle point at 0 0. So to check saddle point, let us first consider what is the mean technique. Suppose I am having a function f of x comma y. Okay, the first thing is find fx, that is partial derivative with respect to x, and find fy, partial derivative with respect to y, and put it 0 and get the solution. By solving these two equations, get the solution. That point, say x comma y, the point, let me call it as c. This is called critical point. Critical point. The next question is, next part is find fxx, that is you are already having fx, again differentiate with respect to x. Will be getting fxx, find fxy and find fyy, and put this value, put c inside it, and try to find one more thing, that is delta, which is fxx, fxy, fxy, fyy. Actually this used to be fyx, this guy, but in this case your fxy and fyx used to be same. So find this delta, and then you have to see the conditions. The first condition is if your fxx is greater than 0 and your delta is greater than 0, then your point c is minima. If fxx is less than 0 and delta is greater than 0, then c is maxima. And if your delta is less than 0, sorry, yeah, if delta is equal to 0 first. Oh. Yeah, if delta is less than 0, then it has saddle point. Then point C is saddle point. Okay. And one more condition is that if your delta is 0, then no conclusion. Then you have to again investigate to get the value, whether it is saddle point or maxima or minima. So no conclusion from this method. Then we have to investigate something else. That's what I will tell you. No conclusion here. Okay. So if your delta is greater than 0, it is minima. Delta is greater than, it is maxima. And if your delta is less than 0, then this point C is your saddle point. And if your delta is equal to 0, then no conclusion. Then we have to think again. Okay. Now let us see. Look at the first function of xy. Find fx. If you find fx, it is 2x minus 3 by 2 y square. Put it 0. Okay, I'm having this equation. Find fy. If you find with respect to y, this will be minus 3xy. And if you're putting this equal to 0, if you see 0 comma 0 is a solution of these two equation, correct? So 0 comma 0 is a critical point I am having. And let us find fxx. What is fxx? It will be 2. What is fxy? You're having x with respect to y, it will minus 3y. And find fyy. What is fyy? Uh, this will be minus 3x. And at 0 0, if you solve, the value will be 2. Here it will be 0. Here it will be 0. So what is the value of delta? Delta will be 2 0 0 0. That means delta equal to 0. That means I cannot apply this thing. So the thing is, what I am having, if delta is 0, then no conclusion. I cannot conclude anything. Then I have to think again something. Okay, now try to observe one thing. Look at your function carefully. F of xy is equal to x square minus 3 upon 2 xy square. Now, if your y is positive or negative, it will have same value. Agree? Look at your function. If I take y positive, then in your function you are having y square, correct? You will be having the same value whatever you are having, and if you have y negative, then also you will be having same. That means suppose I am having point x and say positive y, and I am having x and negative y. In both the case I am having same value, correct? So the value of y does not change the function. Whereas your x is positive, if your x is positive, then we can find this function f of x to be greater than 0. And if you take x is negative, then we can find a point at which the function is less than 0. Do you see? Because if your x is positive, then x square minus 3 by 2 x y square, this may be negative. Okay, I can choose some point so that this is negative, and if your x is negative, then this is already positive, minus 3 upon 2, this x and minus it will be positive, and this is already positive. So if your x is negative, then this part is going to be here. If your x is negative, then I can find a point such that this part is always greater than 0. So I'll just erase it. That means in this neighborhood of 0 0, see, if your x is negative, then this part is negative, so minus into the whole function will be positive, it will be greater than 0 if your x is negative. And if your x is positive, then I can find I find a point such that this f of xy is less than 0. So what do you observe? What is the definition of saddle point? Around that point, around that critical point, you are having both maxima and minima. That is maximum and minimum. So that's what it is, saddle point. Correct? Did you understand? Let me just summarize once again. See, the sign of y does not depend here because I am having only y square term. So I have to look at sign of x. If your x is positive, then this whole function can be negative. I can choose some y such that this whole function is negative. You can put some value also, but just try to observe like this. Whereas if your x is negative, then this will be always positive. This value of f of xy will be always positive, correct? So around 0 0, I am having both positive value and negative value also. That means at 0 0 it is a saddle point. So the first P, P has a saddle point. This is true. Okay, now let us try to see the second one. Again, I am having a function g of. Again, by looking at this function, I can clearly see that again the test will fail. That is, I won't able to conclude anything because it has x raised to power 4, and if I try to find first derivative, second derivative, and so on, I don't think so that every term will go away, and there will be a remaining term of x and y. So if I put 0 0, then your delta will be 0. So here also what I observe that this function g of xy is again having no conclusion. Now in that case, what I have to see, I have to observe the function, I have to investigate something. So this is y square. Now look at this again. In this case, if there is no change, if your x is either positive or negative, the function will have same value. Do you observe? Because I am having x raised to 4 here, I am having x square. So if x is positive or x is negative, there is no change in the function g of xy. Whereas if your y is positive, then what do you observe? And if your y is negative, what do you observe? Look at this. If your y is negative, that means this whole part will be positive. This is already positive. This is already positive. That means your g of xy will be always greater than 0. Correct? If your y is negative, then g of xy is greater than 0. And if your y is positive, I can find some point such that this g of xy is less than 0. You can definitely get some point such that these two people, this the first and last term, uh, add up and subtracted with this guy gives you negative value. That means around 0 0, I am able to find a point which is greater than 0. I am able to find a point at which the function g is less than 0, that means this is also a saddle point. Okay, so g has a saddle point. So answer is both p and q are true. Option A is the perfect one. Question number 11, option E. Okay, thank you so much.